Hi, my name is Anna Cushon. I'm in the Masters of Environmental and Life Sciences at BU, and I am researching the influence of regenerating forests on peatland catchment hydrology in Sudbury, Ontario. Now, Sudbury, Ontario is a very interesting community that was one of the largest mining communities in the world and has been severely affected from these mining impacts due to smelting. And so for many years, Sudbury was basically a barren moonscape until in the 1970s, there was an effort to regreen the area. And we can see here one of these areas that has been restored. And you can see the conifer species that really liven up the area versus an unrestored area. This was taken in the fall, so all the leaves are off the deciduous trees, but it really shows just the difference between the regreened areas and the unrestored. And so through the regreening, there was a really positive impact on the forests in the area, but one thing they never restored was the peatlands. And peatlands are these super wetlands which are able to store a large amount of carbon through their kind of super species, sphagnum moss. And because of the fact that peatlands are always wet, the moss and the different plants do not fully decompose, and they're able to store large amounts of carbon. But unfortunately, these peatlands in Sudbury have been degraded and are actually releasing this carbon. And so that's the main goal of this project, is to restore these peatlands and bring them back to their carbon sequestration power. But what I am specifically looking at is how the regreening of the uplands is impacting the peatlands through how water is arriving. So, and the carbon sequestration is largely controlled by the hydrology of the peatlands. So the change of how water is arriving will impact the peatlands tremendously. So as you can see, there's kind of two good examples of an unrestored hill slope versus a regreened hill slope. And we can see that kind of barren Canadian shield rock versus the regreened, with lots of soil and vegetation and trees, which greatly impact how water arrives and how water is stored through the hill slopes. So you can imagine on this unregreened slope just how fast and how quickly that water is going to flow down into those peatlands versus on this regreened slope where that water is going to be trapped or get trapped by the trees as it falls. So there's just lots more ways for water to arrive or be slowed. So what we expect to see is on these unrestored slopes, they're going to be super flashy rain flow events. So they're going to happen fast and then slow and then be done fast, versus the regreen, which are going to be a lot more delayed as they slowly work their way down the slope and through the soil, but last a lot longer. And so you can imagine how this will impact how water is arriving to the peatlands, and subsequently their carbon storage potential. And so I'm still processing all the data I took this summer, but we're looking at the different water balance properties, so precipitation, evaporation, and of course runoff and storage. So we'll be looking at that and seeing exactly how this flow has changed. And yeah, thank you.